welcome to lesson 20. In this lesson, we'll implement prototype of Erdis, which is very simple key value database server, similar to Redis. We'll do it in Erlang, of course, and I'm saying that it's very simple because the protocol is much more reduced. We'll have only the get key operation, which will return the value of key or a atom does not exist in case the key does not exist in the database. Set key and the value, which sets the value of the key, creates the new key or updates existing one. Size, which will return the amount of keys in the database. Keys will return a list of all keys in the database, and exists returns the true if the key exists and false otherwise. So it is like text protocol. It will be encoded to binary. We will use the term to binary and binary to term, which are Erlang functions. I will talk about this. And for the implementation, we'll use Amnesia for storing the data. Amnesia is basically distributed telecommunication database management system built into the Erlang. It can run on single node or on multiple nodes in the distributed manner. It can store data in memory or on disk. Depends on the type. We'll also use sockets. So you will see how to use sockets in Erlang. Now the product of this demo will be two files, Erdis server and Erdis client. So in the server, of course, we have the code of the server, and in the client we have some simple client implementation, also in Erlang. Okay, so let's start. I will close this one, and I will start implementing Erdis server. Let me start with the module name. So we have the module, and the name will be, of course, Erdis server. We will start with the server. Next, we will have the export. So at this point, we want to export start server with RET 0. So we basically don't have here any arguments. And I think we could also define stop server to, of course, trigger the stop server from Erlang shell. And yeah, that's it for now. So in order, so I mentioned that we will use Amnesia. So the description of Amnesia tables or the schema is basically our records, Erlang records. I recorded the video about the records, so I encourage you to go back to this video if you want to refresh your knowledge about records. So I will define simple record. It will be called entry, and it will be defined by key and the value. So I will have the key and the value, very simple structure. Of course, in the future we can extend it and store maps, lists, and many other data structure. But let's start with very simple implementation. Also, this implementation is a prototype. It's more for demonstration purposes. If you would like to implement really full-fledged and 100% robust server in Erlang, you would use OTP, Erlang OTP, which is a framework for building robust applications. But in order to understand OTP, you first need to understand other concepts. For this reason, I'm presenting this tutorial. So let's do it step by step. There will be also time for the OTP in the future. So the first function I will define is initialize DB, which will create the database for us. So we want here to create database. We also want to start Amnesia on the local node, and we want to create table based on this record. So how to do it? I will use Amnesia create schema, and this will take the node. I will use the current node. I want to create this schema on the current node. It will create the database on the disk of the current node. Next, it will start the Amnesia database management system on the current node. And as a last step, I want to create table. And as a first argument, I'm passing entry. This is exactly this entry, which describes what kind of structure I want to have. Next, I'm passing the attributes. And here, record info. I want to describe the structure in this way: fields, entry. Okay, this is the way I'm doing this. Okay, and I'm going to call this initialize DB every time I will be starting server. So in the normal circumstances, you can imagine that you want to create it only once and then reuse it. But in my case, since this is the demo application, I will be executing this function every time I will be starting the server. And let me now implement the start server. Start server, RET0, no arguments. And as I mentioned, first initialize DB to create database, to start it, and to create the table. And next, I want to start listening on the port. Now I will do the following: gen TCP, which is the module which provides all these socket functions, and then I'm doing the listen. I need to pick the port on which I need to listen. There will be a lot of concepts in this socket programming, which if you're new to sockets, I would probably encourage you to first go and read about the socket programming, because there is quite a lot of concepts like listen, accept, send, receive, and a couple of others. I will try to explain them, but also I don't want to spend too much time on this, because I want to focus on socket programming in Erlang rather than just socket programming. But first we want to tell that we want to listen on the port, in this case 10101. And we will provide a couple of options here as a second argument. Exactly 3 options. So the first binary, or 4 options, sorry, binary, we will exchange the binary data, and we will specify the packet size 4. So very important. In this mode, Erlang will first read 4 bytes to check the length of data which is sent, and it will create the buffer of this length. Then it will wait for all the underneath packages, because you can imagine that if I'm sending a long message from the client to the server, in TCP it won't arrive as a single message. It will be chunked. Now, for the convenience reason, this is one of very cool things in Erlang, is that I can just specify this packet 4, packet 4, and then Erlang will, as I said, create the buffer, wait until complete message arrives. It will fill this buffer, and at the end it will pass the buffer as a message to the function, so that we can handle it clearly. We don't need to read the data, check whether it's already a full message or should we read some more data, and so on. It's very convenient feature of Erlang socket. Now I want to specify, in programming, like I'm implementing this demo, I will be probably often close the process because something may not work. I will be crashing the server. So after every crash, operating system will keep this port, let's say, used. And if I would not specify the next option, which is reuse a DDR set to true, I wouldn't be able to reuse this socket in case it's taken. I want to say, okay, I know that it may be used, but I want to reuse it because I'm doing the local development, and in case my server crashes, I close the server with Control C or whatever. I want to reuse it so that I don't need to kill the process or wait some time. Because after the process crash, which is listening on the port, the port will be occupied for some time still. Therefore, I need to specify this reuse ADDR set to true, and then active set to true, which will create the non-blocking server. So we can have multiple modes here. We will set it to non-blocking or active, and we are opening the socket in active mode. So the controlling process will send the data whenever it will receive it from the client to the process. You can imagine that so controlling process won't wait in any form to until the process, the logic process will process the message. It will just right away, whenever it receives the message, it will send it directly to the process, which could overflow the server with the messages in case we have some hacker or bad actor who wants to overflow the server with many messages. In this case, I wanted to do it like this. First of all, to demonstrate this active server. I will also in the future talk about other modes and how to, let's say, fix this, let's say, or maybe in our case we don't do much in the process, so maybe it's fine. But there are also passive modes for the server which you can also use. So this is our configuration of listen, and the next thing we would like to do will be spawn listening process. So I'm specifying the fun, And here I will invoke the Power Connect, listen, and so this in this case it will create a new process um, for every new client which arrives, and it won't take the process from the pool. We could improve it in the future by implementing the process pool so that these processes are created before listen or accept is executed. As I mentioned in earlier videos, creating process in Erlang is quite fast. Or is very fast, but we could also create the pool upfront, and then we don't need to spend uh, this time on spawning the process. Next thing is the implementation of this Power Connect, so that you see how does it look like. So we will pass here the listen and how next, of course, when we have the listen, we also want to do accept in socket programming. Okay, socket gen TCP accept. So we are accepting the connection from the client. And then I will write 2 more lines and explain what else will happen in this function. We'll spawn here another process like this. Power Connect, listen, and loop socket. So what actually happens here? This process will accept the connection from the client, and it will create a socket. Next, and then it will be handled. This connection for this client, it will be handled in this loop function. But we also want to create another process which will continue listening on the port and create and accept other connections from arriving clients. Therefore, we implement it this way. Next, we also want to implement stop server. Stop server looks like this. Amnesia stop. So the only thing we want to do is to stop Amnesia on the local node. Okay, so this would be it. Now we have invoked loop, but we haven't implemented. So let's see, how does it look like? We have loop, and of course we have this block receive, and in which we will be do the pattern matching for arriving messages. TCP socket bin. We want to do the pattern matching for the TCP protocol. For TCP protocol on the socket, and which we are currently processing, and in the binary mode. So the binary data will arrive here, which will then kind of decode and process. So what we want to do here? When the message arrives, we will just, for the debugging purposes, we will write what kind of message has arrived. Binary p and then bin. So we just want to show what kind of binary has arrived. And then we also want to decode this binary to term, so that we can process it as a string. In this case, we will write binary to term and pass the bin, which has arrived. So this is exactly the data. And we will get the string out of this operation. And then we can take the reply from the processing by typing the process command. And this is our function which will execute the logic of processing the command, so get or set or keys. So this is yeah, and then it will return the reply, which can be then encoded into binary reply. In this case, I will write term to binary reply, so that it can go over the wire. And I can type format server replying. So what kind of message will be sent here? Bin reply. We can also later see what kind of value will be in the string. Okay, and I put it on the standard output, and also I want to send it to the socket from which I got the command for processing. So to the client, send it back to the client. And at the end, I'm calling the loop because I want to wait and process other messages from this client. We also want to handle a situation where the TCP socket is closed. We'll type just some message for debugging purposes. Socket closed. You can imagine that like full-fledged implementation, we would have some maybe more robust implementation at this point, but here we just want to write down to standard output. Okay, so we said that we want to invoke this process command while we are processing the request from the client. So let's see what kind of implementation we have here. Process command, it will take the string, and we will use very simple the parsing technique, which will just split the incoming command, something like get key, and this thing will be output. It will create the list of two strings, get maybe get key. We want to split it and have the list of get and key. Very simple parser, so that we can check what is the command and read further another arguments. For this, I will use string split function. So the parts of the command will be the result of the splitting. The string which came from the client, and I want to have all parts of this split by space. We have command, and the command is always the first first element of the list. For this, I will call the env1 parts, which will return the first element of the list, like get, set, keys, size, and other things. Next, I want to do the case command of to do the pattern matching on this command. In case the first element of the list is get, then I can type something like key get value lists and second parts. So in the second element of this command, there will be, of course, the key which the client wants for which the client wants to execute the get and get the value of this key. In case we have the set, we want to do the set value, and here we want to do lists, and so the second element will be the key list, and third element will be the value. And yeah, so this is how the set works. Then we have the size, get size, and here we don't have any argument. We have also keys, also no arguments, because it will just check what's the server state. We have the delete command, which is similar to get, because it also takes the one argument, the second from the command, which is of course the key, which will be deleted. And the last operation is exists. Here we want to invoke the exists function list, and also only one argument, the second argument in this command, which will tell which key should be checked, the existence of which key should be checked. Okay, so here we are invoking a lot of functions, so now we need to define these functions. For this purpose, I will invoke getValue, and I will in this getValue I want to query Amnesia database. So let's say all operations on Amnesia can be defined as funs, and we can pass it to the Amnesia transaction function for execution. So in this case, I want to get value of this key. So in Amnesia, we would write the fun, and we would define the object ID, and we would say, I want to query for entry with the given key, and the key has arrived as an argument. So I want to see what will be the value in Amnesia of this key. Amnesia will return the list of entries, Amnesia read, and then I can do the case. In case entries are empty list, if this is true, then I want to return does not exist. If this is false, then I want to return first element of this entries. I guess it will be always this only one element, but anyway, we need to specify this like this in this implementation. Okay, let's put end here, and then we have Amnesia transaction, and we want to pass this function to Amnesia transaction for execution. Now this transaction will execute this function in transaction, so if we would, so transactions is basically the set set of database operations, and which is like in case of atomic transaction, it means that either all the operations finish successfully, or the transaction is rolled back, and the state of the transaction and the state of all operations in this transaction is rolled back. It won't be applied on the database. We'll also use transactions for reading. As you can see, we are not even modifying the database in this function. We just the read object, but this is the simplest way to do it. Or yeah, maybe not the simplest. There are simpler way, but let's stick for now to this implementation. When I will be talking about details of Amnesia, I will show also other things which can be done here. Now we want to process also the set key value commands. So we want to set the value of given key. In this case, we will create a new entry where the key will equal to key and the value will equal to value. So we are creating the record with two attributes, key and value. And then we will also create the fun. And in this fun, we will just write Amnesia write entry. And Amnesia will know that it needs to write entry because this was defined when we were creating the table for the entry. And then we also want to do Amnesia transaction. And we want to return key value. In this case, we need to write explicitly what we want to return. In this case, this is also the case because the result of the transaction will be the result of the query here. So I guess it's also worth mentioning. So here we want to say, okay, we were able to set the value of this key. Next, we want to get size. And here we are using the function from the Amnesia module, which is table info about this entry record. We want to get the size. So we are passing the item which identifies which table should be checked and the atom which identifies which information should be retrieved. So in this case, the size amount of keys in this database. Okay, keys. Next thing, keys is like fun. And here we want to also use Amnesia a function which is all keys for this entry. And we want to return okay and the result of this transaction. So it will return the all keys, and the reply to the client will be okay, Amnesia transaction. Another operation we want to implement is delete, and the delete key will be implemented like this. We first create the object ID. It will be record entry and the key which should be deleted. and type fun, f equals fun, and it will be Amnesia delete. Also, we are using the function from the Amnesia module, and then we are executing it in transaction, and we are returning okay key. So this is the way we are doing it. So we are informing here that yeah, we are able to delete this key. Another operation is exists. For exists, we want to type something like this. We check if the value is present by invoking getValue, and if you remember, getValue would return the value of the key or does not exist. And we will check whether it returned does not exist, and we will reply accordingly. So we'll do the case of here the end, and if we got atomic does not exists, it means that the key does not exist. If we got atomic whatever, it means that this key exists in the database. Okay, so a lot of code was written here. If you're new to Erlang, especially, but this is it for the server. We have this implementation based on Amnesia. Let's save the file and let's create now Erdis client. Module Erdis client, and we want to of course export a couple of functions, and here we will export client set. It will be arity will be 2. We want to pass key and the value. Client get with arity 1. Client size with arity 0. Client keys with arity 0. Client delete with arity 1, and client exists with arity 1. Quite a lot of functions to export from this module. And as a helper function, I will implement the very generic function, which will be client eval, which will be the basis for all of these other functions. It will receive, it will generate the, it will just send the incoming input string to the server and display the result. Client eval looks like this. We want to connect to the server, and we are expecting that it will be like OK socket. The result will be, and the TCP connect. For now, I know that this is not the best practice to hard code the value, but let's keep it like this. It's a good exercise maybe to improve it a little bit. We want to send the binary and the packet size is 4. So this is also very important. I was mentioning this packet size when I was implementing the server listen. It's very important that packet size for client and for server is the same. Otherwise, there will be mismatch and nothing will work. Okay. Now I want to send the data. On the socket which I just connected to, socket term to binary, because I need to encode this string to binary. I'm using this term to binary function so that it can go as a binary over the wire. Because you can imagine that wire or the socket they don't understand the Erlang data structure, so we need to convert it to, let's say, common binary. So it can go over the wire and then it can be decoded on the server side. Okay, we are sending, and of course, after we send the message, we want to also receive the message. Here we have the following thing. If we will receive something on TCP, on the socket on which we just sent the message, and it's we have some message, the bin is the message, we want to first write that what kind of binary you received, what's the value, client receive binary, and we want to decode the value which we received. So we'll type binary to term. So we want to make it more understandable for our program, and we convert it from binary to a term, and now we can display it in a more user-friendly way, like as a string. Client result equals p plus n and the val. So we want to display it, and then we want to close the socket. So it will be like execute the client eval, send the value, and then close the socket. Based on this implementation, we can also implement other functions which I mentioned in the export. So let's start with the set. So we want to create a command using IOLib format. We want to create something like this. So it will format for us the set key and set value. And we want to execute client eval to open the socket, to connect to the server, send the message, and then receive the result. So this client eval is doing a lot of things for us. Now we want to implement the get, which is also quite similar. We want to create get message, looks like this, only key is passed, and here we will do the client eval. Next one will be, let's see, client maybe size, which will return the size. It could just size because there is nothing to format. Client eval command, and it will just send the size, and we will get the size of amount of keys in the database. Another one is keys, client keys, which also don't take any argument. The command will be just keys. Oops, here I forgot about this thing, and here command keys, and of course client eval command. Another one was delete, and here we need to specify the key. IOLib helps us format this message. It will be delete and the key. Client eval command. Client, so we have delete, and the last one is exist. We want to check whether this will exist. So the command will, so the client will send IOLib format exists as, and the key. Client eval. Okay, so this is the largest code base in this tutorial, but I think it's good to write also bigger programs while learning, because you can learn a lot. So let's see how will it work. First of all, whether it run. I wrote a lot of code. I'm not sure if it will run. Let's see. Clear. Let's clear this thing. Now we want to run Erlang shell, and we want to first execute our command. First we need to, of course, compile. We want to compile. Let me close it once more. Compile Erdis server. Let's see. Oh, no errors. Okay. Let's compile Erdis client. There are errors. Syntax error before line 36 and line 36 and line 2. Let me note it. Before and function client exist one undefined. Okay. Let's see what's wrong. Clear and Emacs. Client Erdis client. We want to have client exists with arity1. Client exist. Okay, it should be exists. First thing exists. Cool, first thing fixed, and then maybe this is the only thing. client. Oh, I forgot about this. Comma. Okay, comma. So the client failed. Let's see now. Erlang. Let me clear the screen. Erlang. See, let's Erdis client. Okay, now it's fine. Erdis server also we need to compile. Erdis server. So first we need to start the server. If you remember, we need to type start server. Press enter, and there is a problem. Get TCP accept. Error in process. Power connect. Line 17. Let's see. Line 17. Okay, so here what we want to do, we want to connect, handle the parallel connection. We are doing the socket gen TCP accept, listen, and then we want to spawn fun, and then par connect, listen. So we have accept, spawn, let's see. Let's see here. We have the listen. On the start server, we want to listen, and then we are passing this listen on this port. Could it be that there is something with port? Let's see. I will use a different port. No, there is still some problem. Undef gen TCP accept. I must have accept. This is get TCP, not gen TCP. So typo from my side. You can see that everything is live here. when nothing is ready. Erdis server. Let's see. Erdis server. Start server. If you remember, start server will also initialize the database. Okay, now the server has started. Let's now, we have compiled our client, so we can already refer it by a module name. And we got the functions like client get, client set, and a couple of others. Client get, for example, we want to get the value of undefined. We don't have keys yet, so we will, okay, we have some problems. We have exception. By the way, I will be talking about exceptions in next video, so stay tuned. Error in process with exit value, bad match. Erdis server power exception. Get TCP connect in Erdis client. Okay, let's see. In line 5. We specify the host. We want to specify the port. And we want to specify options. And there is something wrong with these options, or let's see. Again, get TCP. It should be get TCP. I'm writing too often. It should be get again. Sorry, GN. Let's save it and once more. Let me clear the screen. And now Erlang compile server, compile client, start server, and now client, for example, get undefined. And as you can see, I have the result. So first I got the binary output. Server received binary. It's the output from, since I'm running in the same Erlang shell, I'm also and on the same computer. But these are two different processes. You can imagine two different programs which are communicating via socket. That's why I have created here the server, separate process, and here the client, also separate process. And here I could also run this as totally separate programs in operating system on totally separated computers. So the server has received the message, which is the binary in the binary format. I could also here it's also I could also just write it decode it, but yeah, let's keep it encoded for now. Server replying, what kind of reply there will be from server. So we have this information atomic, it's encoded message. It's like atomic and then does not exist. And this looks more like this. And also this is the binary representation of this. So of course this key doesn't exist. First I need to set something. Set name to Michał, for example. Okay, I got okay. Name is now Michał. Now I will do the get on the name. And I have information that my name is Michał. I could also maybe create some name 2 or age, another key, age 36, for example. Now I can also take the value from the age, and it will give me the record type, information that this is atomic, a record, and the key and the value. Now I can check the size of my database, and here I have error with exit value, line exception error, undefined function size. Seems to me that I don't have size. Let's quickly try to fix it. I don't have client size. There should be client size. Of course. I shouldn't specify the parameter. And now I have another error, no match of right-hand side value. In function client eval. Let's see what could be wrong with this size. Command will be size, and then we are passing client eval. Command. And then we have on the server, let's see if everything is fine with this size. Get size. Get size. We have the function table info. Amnesia transaction. Okay. Amnesia and then transaction. Here we have socket. We couldn't connect for some reason, I guess, because on the server, no, we got the error. What could be the reason for this? Okay, let's also check other functions. We have size. We have also get keys, right? Keys also is failing for some reason. Connection refused. Okay, something is wrong with the server could fail. Let's restart this. Yeah, so this is very simple implementation of the server, so there is no controlling process. If something fails, then even server can stop. But for the demo purposes, I guess it's enough. Erdis. We'll start the server. Erdis client set value key value function set value to Erdis client set value I got client set set value Erdis client yes it should be not the set value but client set, wrong name. Right. Connection refused. I guess I will start. Let's connect on different port. I guess it could be something related. Also, server needs to run on different port. Okay, now Erdis server start server. Erdis client client set key value. Now the value is set. Okay. Server socket closed. Okay, that's good. Now we can also set key 1, for example, value 1. Now we can do the get key 1, for example. We got the value 1. Now we also can do the size, client size, to see the size of our database. And we got the OK and then atomic 2. So we have 2 keys currently. I could also define another key. And if I do the size, I will get size increased. Now let's see the keys. Let's list the keys in the database. I got the OK, atomic, key 2, key, and key 1. It's not in sorted order, but we got all the 3 keys. And I want to know whether key 2 exists. Okay, I got true. Looks very nice. Key 3, I got false because it doesn't exist on this list. And the last thing I want to do, delete key 2, for example, and then I will do list of all the keys. And now I have only 2 keys in my database. Okay, so with some troubles, we were able to implement this very simple socket and amnesia based application for the key value store. As you can see, we had quite a lot of errors and exceptions in this part, so I guess it makes total sense to focus on the exceptions in the next video. So stay tuned for the next video. Thanks and bye bye.